Dr. Ghosh. Welcome to Stories in AI. How are you today?
I'm doing terrific. How are you?
I'm doing fantastic. I mean, what a great day to be alive, and what a great day to be in Austin today, huh? It's not middle of July, and it's still not 118 degrees.
Right. I was actually outside today because it was breezy and I'm by the lake. So I'm slightly outside of Austin. And it was in the early 80s, which is quite amazing for mid July.
Right? And although the flip side of this is there is definitely the weather pattern changing, and a lot of the changes are way earlier than we all are expecting it to happen, but the evidence is in front of us right now, right? So I've been really looking forward to this recording, and thanks for making the time today. And you're one of the very early people that I met during my career in AI, and we worked together in the past, with your association CognitiveScale at UT Austin and stuff too. Um, Give us your personal story. Start with your personal story. Tell us why and how you got into AI, and just give us that journey.
Sure. So I started working in AI seriously as a graduate student at USC in the mid 1980s. And at that time, the big threat was not China, but Japan. And the Japanese had started what they call the fifth generation computing project, FGCS. And that was all AI and logic based. And we worked on more traditional AI. In particular, we were trying to design hardware which could run Lisp and Prolog, which are AI languages, very efficiently.
Hmm.
That's where he started. And as you know, at that time, the hot AI technology was the knowledge based systems or expert systems. And then they overpromised. They actually did not underdeliver to the extent people think, because there are lots of practical systems that are based on rules or other types of expert systems right now. But they did overpromise, and then the whole area declined, which was the so-called second winter of AI. But before that happened, in 1987, I was in Los Angeles, and the first IEEE conference on neural networks happened in San Diego, and I happened to attend that, and I got really excited. There's also, of course, all those analogies to the human brain, which turns out to be really very tenuous and not very strong, but they do get you enthused about the area. But I was I slowly moved into the neural network technology as it started in the late 80s. And I was part of the second hype cycle of neural networks, which happened in the early 90s with a bunch of good applications. On the hardware side, it turned out, and this is one of the lessons from industry, that even though we designed these special purpose chips for Lisp and Prolog, they all got killed by the killer micros from Intel, because Intel was cranking them out at such high volume and such low cost that even though they weren't tailored for AI,
Optimism,
they
yeah.
were good enough generic chips. So that whole industry went away. And now, after 20, 25 years, now we see the real maturation of the idea of having special purpose neural chips, whether they'll be in your phone, like the Apple A series
M1s,
chips,
yep.
in your iPhone, or they can be in the server farms from NVIDIA and Google. And a lot of the cloud computing are running these special AI chips. So the idea was a bit ahead of its time. But anyway, I basically moved more into the statistical. Basically, these are fancy pattern recognition techniques, these neural networks. And that's in 1988, I became a professor, and I did something which I would not advise any faculty to do, which is, as a untenured professor, I changed my area from high performance computing and parallel processing computer architecture to pattern recognition AI. As opposed to hardware for AI, I went into the algorithms and statistics for AI. And now, after 20, 25 years, we've come through a full loop where the amount of data and compute is so strong, so much that you to be a good machine learning researchers, you need to understand the compute, the data storage issues, and of course the algorithms in the application. So both those backgrounds are finally coming together now. So now I've been a professor at UT for more than 3 decades, working in AI machine learning. The usual professorial stuff, which is you write a lot of papers that not too many people read, but I have more than 500 refereed technical papers.
Wow.
But probably more important, I've really enjoyed using these insights to solve practical problems for industry and government. And part of that, I became chief scientist of CognitiveScale, about 4 years, more than 4 years back. And that allowed me to come into contact with a lot of industry folks with their real life problems and thinking of how to solve them. Mm, And there you realize that AI is just, well, it's a very important and increasingly important tool, but it's just one of various tools that you have to bring into bear to actually solve a real life problem. So it is an important tool in in a kitty bag of tools that you need as a problem solver.
Oh, it's amazing. And you bring that very unique vantage point, right? Your experience, the depth in which, and like, thanks for taking us a little bit into that journey. I want to explore that a little bit more on the history, right? What have you seen across that entire thing? But before you do that, I think that that unique vantage point you bring in is being so deep in research and the academic circles through,
Mm,
especially those winters when a lot of work happened, right? And then
yes.
getting into the hype cycles when the industry starts trying to adopt it and then go back and so forth. So you were in that constant journey of the troves and the peaks of going through it. So what was that? Tell us the history of AI from your vantage point, from you, all the things that you worked on, both on the academic side and the industrial side. Give us a tour of that.
Well, the quick history, the early works in AI were much more data driven like what we have now. And I'm talking about the 1940s, 50s. So a lot of, if you think about adaptive control, adaptive signal processing,
Hmm.
these have ideas which are now used very much in standard AI, like, stochastic gradient descent comes out from signal processing. Um, but in 1956, there was this famous workshop in MIT where Minsky and others felt that the way to think about AI is through symbolic reasoning. So AI became symbolic reasoning, logic, and search based, as opposed to data driven, pattern matching, neural network based. And that was a big split. There were a whole bunch of people who worked on pattern recognition ideas, mostly in more doubly or engineering contexts. And these search based ideas did make a lot of progress, and they've solved very large constrained satisfaction problems for the military. For example, a lot
Hmm.
of the Iraq war deployment, a lot of it was AI based, some of the NASA missions and so on. But people have realized it's very difficult. The Psyche project, which was actually based in Austin, they realized it's very difficult to capture all the knowledge in the world in a way that you can use it, capture completely and
Yeah.
use it. So people have come up with the limitations of those approaches, and now the cycle has gone to the other direction where we are primarily, nowadays when somebody says AI, it usually means machine learning. And when somebody says machine learning for AI, it usually means deep learning, right? So it's very, very data driven. And at the same time, you should not, since I've been through this hills and troughs, at every point, there were some useful technologies that are still being used, and at some point, we'll say, yeah, but I need a bit of that common sense reasoning. I need a bit of that, trying to understand how to incorporate domain physics or biology or business rules into my solution. Now, I just don't want to throw a lot of data and some fancy algorithm and compute power and accept whatever it spits out. So I think we are going to go back to have a bit more of the more traditional and newer ways of representing and inferring on knowledge, to the current paradigm, which is primarily is dominated, I would say, with machine learning, deep learning, some with sensor technology and robotics as well. But primarily, whatever you do, whether you're doing language, you're not doing Chomskyan type of language.
Yeah.
You're doing deep learning transformer type
Yep.
of language, right? It's very, very data driven. No, but there was something also to try to understand the inherent deep structure of language, which is very common across human languages because humans have very common ways of thinking and processing information. So we need to, again, going forward, some of that I think will come back in the next generation of AI that'll happen.
Interesting.
The other thing I wanted to quickly say that what's being broadly called machine learning and data science, a lot of the core ideas have been there from different communities like statisticians, pattern recognition people, social scientists who do a lot of data driven. So some of it is new, some of it is old. One of the good things is that statisticians, I actually really admire them. They they have a very well defined deep theory for over in many decades.
Hmm.
But I think in general, they were sometimes your history holds you back because you have so much that you are unwilling to take bold steps and do things which may not be may seem a bit foolhardy. But with machine learning, one of the things it's done is it's excited a lot of people. And instead of thinking about everything in a very systematic way, they say, "Oh, let me try these 20 things," and sometimes something sticks. And then if it works great, then people retrospectively try to figure out what happened and come up with new wisdom. So I think it has really helped in broaden the ways of trying to deal with data-driven approaches. But at the same time, there's a lot of good ideas from other communities that we should always try to. So you can think of AI or machine learning at least as a much more modern view of stats, and that's why sometimes some people call the methods statistical machine learning. Yeah.
Interesting. No, that's actually pretty fascinating. And like you said, like all the work that has happened over 3, 4, 5 decades is finally these hype cycles also help in getting all to the forefront. People start digging deeper into history and research to learn from patterns, no pun intended, to draw out of and then try to actually put that in practice, right? Um, Talk a little bit about the hype and the crashes or the winters themselves, right? What caused some of these? Is it too much hype? Is it not really catching up to the hype in terms of what value is being realized? Uh, Talk to a little bit of that.
Yeah, a little bit. So, the winter in the late 80s, early 90s is well known because of the overpromise of knowledge-based systems, right? Expert systems. But maybe I'll talk a little bit about a more recent thing, and
Sure.
partly because this morning there's a lovely article in the New York
Where's
Times.
Watson?
It's on Watson. You saw that,
That's
right?
all.
It's called Whatever Happened to IBM's Watson. And I think the person does a really good job because turns out, when Watson beat the human expert in Jeopardy, which was just 10 years back, mm, that was amazing. But people inferred too much from that capability because that entire solution was tailored for Jeopardy, right? It was not tailored for any other,
Application.
not
Yeah.
even any other, no Atari game, no Go, no chess. It was on Jeopardy, and there were a lot of very good, reasoning and QA behind it. But then what happened is the hype took hold, and of course IBM has learned that, in a very expensive lesson. But apparently, just the very next day after the victory, IBM came with a big ad saying that we are trying to use Watson to solve healthcare, finance,
Dr.
blah blah
Watson.
blah. Yeah, Dr. Watson, and there were all these TV ads with Serena Williams and Bob Dylan and so on. They bought, and then when the things started faltering, they said, "Oh, maybe we don't have enough data." They spent at least $4 billion that I know of acquiring companies whose main assets were they had health data or
Weather
they had a
data.
large
Yeah.
database. So they were basically paying for the data. And then you can see how the messaging has changed because initially it was Dr. Watson can solve big problems, futuristic problems that human experts cannot, right? So they are smarter than the experts. And that has a lot of issues. For one, for starters, they get the experts pissed off. And if you have a solution where you need the human experts like the physician's help to implement it, and this is going to replace them, they probably will not be very happy partners. But anyway, that's
Hmm.
on the side. But I think later on they realized that even some areas, the real life data, there's a lot of issues with genetic data and so on, um, other than privacy, just the data quality issues. But um, they realized even in cases where IBM Watson could do better, maybe make better recommendations than the human experts, patients are much more comfortable with physicians, right? And maybe I'll allude to a Harvard Business Review that also came out recently, which talks to this. This is based on a big patient survey. So you not only have to be better in a technical sense, and Watson was not better in everything that they tried, but in some things they were. You also have to have the properties where humans will accept you, have comfort with you, and you have to be way better than the human expert, or way cheaper, or some combination of the two, for this technology to be accepted, right? It cannot be incremental.
Hmm.
It has to be, extra performance plus something else, maybe more reliable, maybe 24/7, does not go to sleep, all those things, but multiple of these factors for the technology to be successful. But Ganesh, as I'm sure you followed the IBM story, you saw that a few years back when Ginny Rometty was still the CEO, she started changing her message and saying, okay, AI will work with humans to deliver solutions
Yep.
rather than my smart Watson will take over your medical doctor, right? So you can see the messaging changed. And right now, the messaging has gone to the other end, where instead of AI solving these big, tough problems, this is so I wrote this code because I really like it. So apparently, the IBM's latest ad says uh, Watson helps companies automate the little things so that they, which means the companies, can focus on the next big thing. So in some sense, there's a role reversal. But from a business viewpoint, I think this is because there are a lot of little things which, if you can take care of, it brings a lot of value. They may not be glamorous. It's not the next go algorithm, but these are very, very valuable from a company's viewpoint. And if you look at the success of RPA companies,
Yep.
uh, that's billions of dollars. Though you would say that what they're doing is not very glamorous, and maybe not even much AI. Well, a lot of it doesn't have much AI, but if it is valuable and you think these are reasonable, have some smarts, whether it's a smartphone, which by definition is smart in its name, or is just smart business process operations, those are valuable to. And I think that's some of the near-term value of AI to the corporate world.
I'm really proud of what the work we did at, together when I was there still at Cognitive Scale, right? But the whole focus was all about what we called augmented intelligence. And not a lot of people were talking about it when we started talking about it. And the notion that like put the human in the center of this and then try to actually, play the role of Jarvis for Iron Man rather than,
Right.
Terminator and Skynet, right? So it was a, to it's interesting the IBM ad that you called out where let AI focus on the small things so you can focus on the big things. And in some some way it's actually an acceptance to where the state of the market is, what is possible today with AI. But on the other hand, it also is really putting the human intelligence, human ingenuity, human creativity right in the center of everything, right? And then say, look, let's design around it. And to your point, you're exactly right. It doesn't like AI. I mean, this is how high cycles are born and busted, right? Wherein you focus on the technology, then the value it's delivering to
Yeah.
organizations or individuals. So on that note, let's do a gut check on where AI is today in terms of what is possible. Give me a spectrum, right? What is possible? What is working? What is right at that frontier, but not there yet, but we could actually go into? Give me some examples.
Okay. Actually, let me just finish the IBM story because
Sure.
what I read is that now they have like 40,000 customers who use the current solving small problems version of AI. So finally, after all these years, they're actually getting quite a bit of traction. While the initial Watson deployments were this big picture, genomics, cancer, which were highly service oriented rather than product oriented, but the number of customers you could pretty much almost count on your hands, right? Yeah. So I think if you look at, well, in order to see where we are now, you want to see what are the biggest progress that has happened in the last, 7, 8 years. They've been primarily things that relate to human senses, right?
Mhm.
So vision, image processing. Right now, the best, image processing vision algorithms are AI based. And so recognizing what's happening in a scene, what are the objects, what are the relationship, uh, you know, for example, detecting while you're driving your autonomous vehicle, they are AI based. Um, and it's very interesting because my colleague, who's a famous professor in image processing, he had to totally change his course because initially there's no mention of deep learning. It was all the standard filtering and image processing.
Okay. Yeah.
And now more than half the course is about deep
Deep
learning, right?
learning.
The second one is language processing, and that includes understanding language, language translation, question answering, conversation, and so on. The third one is speech, speech understanding, speech transcription. So in all these three areas, not very abstract language like irony and so on, those are a bit more
Really
challenging.
complicated. Yeah.
But standard actually the AI solutions are doing better than humans or human experts at this point. So to give you a concrete example, I visited Microsoft about 4 years back, 5 years back, and at that time, their system for understanding free-form speech had just got the word error rate went down to under 5.7, which was the rate for human experts, and this was 5 years back, right? A lot of the visual question answering, so you can have a picture and ask fairly complicated questions. You say, what do you think? Why do you think that person is sitting in the park, right? Some bit more
Abstract
complicated,
questions. Yeah.
are getting more and more abstract. So which basically you need to understand both language as well as images or video. These are, you're doing amazingly well. The other thing is, of course, because of sensors and robots, that technology, and of course, they also need the image vision applications. That has also made quite a bit of progress, at least for very mundane. So one of my colleagues just took leave permanently from our faculty. This is Andrea Tomas. So she has a company where they make robots to help in hospitals.
Hmm.
So with COVID, some companies actually got a jump start, and here suddenly the robot could handle, just simple things like moving towels from one place to the other, or robes in the ER and so on. And they can be done much more reliably, safely, cheaply with robots. So I think that is also robotics. By the way, people think of robotics as AI, but if you think of industrial robotics, has been in industry and mechanical engineering typically for donkey's years, right? Ever
Yep.
since we had these automated assembly lines for cars and so on. So industrial robots has, but nobody think of that as AI because that is just very mundane, gets the
Programming
job done
systems. Yeah.
reliably. That's it. But if you have a robot playing soccer, you say, "Wow, that must be AI,"
Yeah.
right?
No, it's
So, yeah,
I'm a mechanical engineer undergrad, and I wrote CNC programming in Fortran and Pascal back in the day,
yeah,
right? So I mean, you
yeah,
don't
yeah.
even consider any of that even close to what is driving automation and AI in manufacturing. Um, no, it's interesting you say that. So on the domain itself, right? Like so, let's pick let's say language for example, right? So we're
Right.
all the work. I think 2018 is when Transformers, the paper was published on Transformers,
Mhm.
and
Yeah.
there's been a lot of progress there. So explore that a little bit for me in terms of like what is the significance of that progress? Because I mean the artifacts of that look like GPT-3, which doesn't make a lot of commercial sense for anyone other than like like a Google, right, or OpenAI, right? But what's the
Right.
significance of some of the work that has come out of that, right? Especially Transformers. Um, talk to a little bit of
Yeah.
that.
Right. So basically, the idea with language was if I have enough data and enough examples of text, then I don't need to know the underlying grammar and I can still do useful things. For example, transforming from one sequence, say one sentence to another sentence. And that other sentence could be a better form of the sentence, maybe the next sentence in a story.
Hmm.
So, story generation, it could be a sentence in a different language. So, language translation and so on, right? So the earlier ideas were not had some issues in terms of scaling, also understandability, interpretability, and so the transformer technology helped address some of those, and that enabled people to feed in much bigger chunks of text. So GPT from three from OpenAI, which came out last year now.
Next
With
year.
COVID, my sense of time is a little bit off
All of ours.
Mm, yeah, yes. So that one, they fed in about 500 billion tokens, which are like little pieces of text. So pretty much anything that's out there in the open internet, plus a lot of code bases and other type of
Yeah.
databases. And it can do amazing things. There are actually business opportunities there. Maybe I'll mention a couple there. But really, what it is, you can think of it as it is still doing pattern recognition, and think of it as a very fancy autocomplete. It's the world's smartest autocomplete, right? So what you do is you give a piece of text, right? And then you give a few examples of what you would want to the autocomplete to be, which is like a textual response to your piece of text, right?
Hmm.
And you, because it's been trained on so much data for 1,000 petaflop days, I think, so lots of training with lots of data, it can do a very large variety of these so-called autocomplete. So autocomplete might look like really stupid thing to do, but if you think of it in a general way,
It's a hard
so
problem.
a piece of text would be a badly written sentence, and then the autocomplete would be the proper form of the sentence, right? So grammar correction. Piece of text, as this could be language translation, but more interestingly, a piece of text could be something that I want my SQL query to do, and then the training example, the next piece, the answer, desired answer would be the actual SQL code.
Mm.
So once I give a few examples of this, the next time I say, hey, this is what I want, and the answer that GPT-3 gives will be a SQL piece of SQL code. Even fancier, I can, say I want to design an app, and these are the things I want in an app, and then the answer is the code for the app, and I do a couple of these examples. Then I want to build a new app, and I say, hey, this is what I want this app to do, and it's actually going to give you the code for the app. Okay. Now, this may not be, obviously, this is not coming from a software engineer, so there may be, it hasn't been QC'd, there may be some problems, but it's almost there. So now you can have somebody to, do some sanity checks, run some tests, but you can get that code out and mature in a more mature form, in maybe 20th of the time. So one of the, I think, the business value of GPT-3 is that it can facilitate or accelerate the dreams of the low code, no code environment, which is, by the way, one of the things that CognitiveScale wants to do. So, in fact, Ganesh, so I'm the chief scientist of CogScale, where Ganesh was VP for sales and marketing,
Business development
product,
marketing.
yeah,
Yeah.
biz dev. We were talking about MLOps 5 years back. Now, in the last 2 years, all the big companies talk about MLOps.
Mm.
I wrote an article on trusted AI and what are the 6 components to make an AI solution trustworthy, and that was 3 years back. And
2018.
now people realize that to have human acceptance of the customer as well as the business owners, you do need to check for biases, drift, explainability, fairness, and so on. So one of the other things we wanted to do is to have a very low code development. We can very quickly um, build solutions for business problems, and GPT-3 will facilitate some of that. Now the thing is, again, just like IBM Watson, people can read too much into it, and say, wow, this thing is really smart, while it's just doing very smart brute, but still brute force pattern match. And that's why OpenAI, if you read the actual announcement, and the technical paper that came with that announcement, roughly a third of that announcement is dedicated to where this can go wrong and why this needs to be controlled. And that's why the release is not public domain. You file an application, you say, this is what I want to do, this is how I want to do
Yep.
it, and they'll try to vet you. Why? Because they don't want this thing to be going, doing unanticipated things, as it's already done in some situations.
Yep.
So one example is there was a started conversation on mental health, and then it was suggesting that people just commit suicide and solve the problem, which would solve the problem, but maybe not in the way you intended to, right?
It optimized for
Uh,
the outcome, right? I mean,
yeah, exactly. So they are, I think, going in with their eyes wide open this time. But sure, yeah, I think other than the glamour, this will have a lot of business use. For example, in just general as a general productivity tools, where I can give a few. Think of it as a very smart training. So you give your apprentice a few examples, and then it can run with it. The result may not be fully polished, but then you can just, you know, put some gloss over the result and make it presentable.
No, it's amazing. I think there is I mean, this is definitely um, a fascinating place, right? And a lot of the efforts around the industry, from private and research organizations, they're all pushing the ball forward, and pushing the needle on, moving the needle forward on trying to do what can you really do by making AI to be in service of humanity to something better and make their
Right.
life important and more effective. But you touched upon a few things. I want to enter into that conversation on trust, right? What can
Yeah.
go wrong? I mean, we've seen some of the examples you gave. How should organizations really approach that? And a lot of these things, that six, if you don't mind just elaborating that six principles on trust. And I remember we used to talk about it a lot 4 years ago, 3, 4 years ago. So one, just explain that principles of trust or trusted AI. And second, uh, they're all in different levels of maturity from a research standpoint, right? So,
Right.
what can organizations do today to embed those principles in? To start with the six principles.
Yeah. So maybe I'll start from even before
Sure.
that. So there are two notions being thrown around. One is called ethical AI,
Yep.
and the other is called trusted or responsible AI. So the ethical AI is much more principle like, it's like the principles of three rules or Asimov's principles of robotics,
Yep.
right? So the ethical AI could be something like, okay, you should not harm humans. But the thing is, it's at a very abstract level, and how do you translate that into your products is more challenging. Also, I think last I heard from the World Economic Forum, which I work with quite a bit, they had 176 distinct principles of ethical AI coming from various governments, NGOs, et
Yep.
cetera, right? So the second term is this notion of trusted or responsible AI, and I think that's much more on the application side. So if you want to develop an AI product or a slew of products, or you have an AI company, what are the things you should be checking for, right? And I put them broadly into five buckets. One is you want to see whether your model is reasonably understandable, explainable, transparent.
Hmm.
So that's the explainability, and that means the model as a whole, as well as individual decisions made by the model. Now, obviously, if you have a very complex model like GP3 T3, it'd be very naive to see that it
Explain,
can be
right? Yeah.
explained in a PowerPoint slide, right? It's just not. If it was, then if you already knew it, you wouldn't have to develop this, right? But at least to some extent, you can get some. So humans have comfort with not only what it does and how it does it, but also where it might go wrong.
Yep.
Okay. The second thing is bias. So you want to see if it's making decisions. So, for example, granting loans or scholarships or insurance policies, that it is not systematically biased against some group versus the other, like based on race, gender, etc. So that's called bias or lack of
Fairness.
fairness.
Yeah.
The third thing is what we call robustness, and that's just where you know whether the solution is easy to go off rails or not. Some of the very well known examples are some of the deep learning based image recognition techniques. So you can have a stop sign and you can put a very thin transparent film on it with what seems to be me as noise, but now the computer algorithm will read it as yield rather than stop. In fact, what you can do is you can take any image, say image of a donkey, and then give a target image like image of a car, and it tries to find a minimal perturbation to the donkey image. So the algorithm says it's a car.
Yep.
To me, there's no difference. It still looks like a donkey, right? Maybe it's just a very slow car. That's what a donkey is. But anyway, so so um, and the thing it does is that these are mathematically in such high dimensional spaces that they could be different directions where you can move from the donkey space to the car space, and some of those directions may be mathematically there, even though they may not make sense to humans. But since it's such high dimension space, there are many possible directions, and some of them can really throw you off. That's basically, in a nutshell, how these things work. So you want to see that your model is robust. You want to know about, and that relates to the amount of risk, because maybe most of the time it behaves fine, but sometimes you get an answer that is way off. And if you're using this for your option strategy, you might just lose all your money in one way of call, right? So this is very important. So I had talked about explainability, fairness, robustness. The fourth one is if you're, which is more on accountability and governance. If you're in a highly regulated industry like finance. The fifth one is all the data related things like data privacy, data leaks,
Lines,
and
yeah.
so on. Again, depending on your application, some may be less important than others. And the and the last one we add, even though it's not a responsible AI part, is just the original performance, your business
Yeah.
metric, right? Whether it's accuracy or dollars or whatever, because we should not forget, because that's where we wanted to
Where we
go.
started.
So I could maybe give you a solution where we started, right? And I can give you a solution which is, you know, it basically gives a constant answer. It's totally robust. My answer never changes. It gives the same answer whether it's a man or woman, but it's totally useless, right? So it could be fair and robust, but it doesn't have performance. So we also always want to keep track that we also interested in performance while trying to enable trust and reliability into the system. So these are my six. So explainability, bias of fairness, robustness, and part of robustness is modeling model drift and data drift and so on. So things might be fine now, but not in a year's time. And then accountability, governance, and then data issues and performance.
Performs. So I mean, a lot of and these are not just related to the model, right? This is the entire system that encapsulate the model, the data, as you said, because accountability, for example, right?
Right.
It could mean, yes, there is the accountability for the model for making certain decisions, but that may be going into a semi-automated decision system and somebody else is responsible for making a decision. So this is a broader construct than just machine learning systems, right?
So the first three things that I talked about, bias, explainability, and robustness, that is for a specific predictive model.
Hmm.
Okay, so they're much more tied to the statistic properties of that model. The governance and the data aspects are much more at a corporate level. So they're at a systems level.
Mm.
What are your rules? What are your processes do you have? When do you and how often and how do you document things? Is there a manual override? Can you roll back? So these are processes, and many of them are at a corporate level. They're really not speaking to a specific machine learning model. Okay, so if you see some of the people who have solutions in the area, they come from much more of a consultancy side, like PricewaterhouseCoopers.
Hmm.
So they will ask you a bunch of questions, and that relates to much more to corporate policies, and they're not questions about a specific algorithm or model that you developed.
True.
Okay, so again, I would, in my first cut of separation, I'll be some which are statistical model based, and some which would be much more procedural, structural, systemic, and corporation based or process based.
Got it. Got it. No, that makes a lot of sense, Dr. Ghosh. And one other area that I want to actually spend some time, from because you have both the practical industry expertise and experience and the research experience is this notion of reusability and repeatability in machine learning,
Right,
right?
right,
Most AI projects still are very much data science driven, which means you build a model specific to a problem, you solve it, you put it in production, you make it happen.
right.
Um, but it's very rarely repeated. Another problem, different context, different set of data. You may need to modify it, start afresh. I mean, it's led to a snowflake of ML efforts all across enterprises, right? Where do you see
Right.
that problem right now in the industry, and how can we solve it?
Okay. So, yeah, this is actually a problem. And also, it's partly the nature of the business. So, one of the things we learned in the pattern recognition community And one of my mentors wrote this in a paper from 1973, that in this business, really what we have is a bag of tools and a bag of problems. And what he basically said is that there's not going to be one tool that's going to solve all magical tool that's solve all your problems. Once you have it, that's the end of the road, right? That's just the very nature of it. And now, this was written in 1973, and now this is a broader acceptance of this idea. But there's some things that can be repeated. Firstly, there's some microservices, which is not a solution, but things that go into solutions. And those things could be fairly generic. So if you look at what's offered by Google, Microsoft, etc., like sentiment analysis, right? Object recognition in images. Think of these are like little pieces of conversation. These are and then what you do is you use it to solve, create solutions. But you don't have to redo your conversation robot or your sentiment analysis piece. Okay, so those by nature are repeatable, but they're also by nature very, very narrow in the scope. Okay. The second thing that's repeatable is certain processes where you say, for this kind of problems, this is the kind of solution.
Class of solutions, yeah.
A class of solutions. Now the exact solution, there'll be some fine tuning, right? And then a particular concept of that within that is this whole idea of transfer learning, which has really helped machine learning, especially areas like vision. So what happens is, especially in vision, there's been this huge data set from, I think, 2011 called ImageNet,
yeah.
which are examples of many types of objects. And once you train on that, now if you have any new problems, so since I picked donkeys and cars, my new job is to separate donkeys from cars. Well, turns out that, of course, I built an image nest for 20,000 classes, but turns out that a lot of the features that are useful for those 20,000 are very useful for separating donkeys from cars. So a lot of the hard work that I did there can be reused or transferred from that problem into my new problem. So that's the idea of transfer learning. So basically, you identify some public domain data set and solution, which is reasonably related, and copy most of the solution from there, and just then fine tune that solution a little bit to have your custom solution. And this idea has been very popular in not only image recognition, but also some of the language problems as well. So that is where, and eventually, we need to think of fairly core capabilities, and a lot of the art is going to move into how smart are people in composing these capabilities and add the right type of glue to build reliable solutions in a very quick time frame.
No, you touched upon multiple interesting things there. One is like the advances in research, definitely. Things like transfer learning will allow us to have a better starting point for problem solving than having to start from scratch every single time, right? On the other hand, there is the composability nature. So that's where like a lot of the ML ops work is also happening. How do I provide a software infrastructure to compress a lot of the repeatable tasks and then just focus on the ones that you need to actually focus on for the particular problem solving? But I think there is also the other, broadly, I think there's a realization coming together that this whole space of AI and machine learning is very much an iterative science, right? So the traditional notion of building products, which is you get a central team, build write software, build something, throw it over the fence. It's not going to work with AI, right? Because you have to constantly learn, and then the data changes on the edge when you're in the inferencing side. It changes the shape of the problem itself. You got to redo this thing. So how do you really comprehend the nature of the problem and accept it being a very iterative one? And then you design with that design mindset in mind, where, hey, you have to have building blocks and you build on it, you configure it, but then build that entire lifecycle management into the product itself. So I think that's we are seeing that all over. But the rise of MLOps in the industry, for example, there's a lot of focus on trying to make it as repeatable as possible. So this is
yes. So actually, it's related to two notions. Actually, both of them I touched upon in my previous where
commentary.
When I said we have a bag of tools, beforehand you may not know what is the right tool. So you have to do some experimentation. So as opposed to the standard way of software engineering, you have the waterfall model. So you spec out everything in great detail
Yes.
before you start even building the first piece. But here, if your data scientist says, "Well, I need to try these. I think these are the three best possible solutions." But in order to know which is the right way, I have to actually try them out. He's not bullshitting. That's just the nature of
Yep.
the game. He's not just trying to, make a fool of
Yeah.
you. That's so that has to be part of the process. Now, some of that experimentation is getting more and more automated. So if there are three possible cases, AutoML will try all three for you, or in fact, try 10 possible possibilities and give you the one or the top two solutions for you to work with. So it can facilitate some of that. So that experimental nature and the thing that you cannot fully specify everything before you start building, some of that will be hidden, go under the covers, because that discovery process will become all automated. So as far as you're concerned, you press the AutoML button. It's still not there, but it's getting there, and it has done all this and come up with a solution. So in some sense, the box told you the box is the placeholder for the solution, and then you can spec around that solution, the ML solution, to get your overall business solution. So again, I'm not sure if this is part of reusability, but it does have some of those features.
Yeah. No, I agree. I think AutoML definitely is a big. It's the big moment that movement that has happened in the last 4 to 5 years,
Yeah,
and I think still I believe though the focus of AutoML today is still about trying to make the data science folks more efficient and effective, right? So
exactly.
you're removing the
Yeah,
tasks that they otherwise have to do, but still the notion of actually how do you really uh, reduce the amount of expertise needed or domain or the problem solving expertise needed to really solve the problem, participatory problem solving with the actual end users of the solution itself. I think that with the no code and low code revolution, I think that is hopefully we can actually go solve that too.
yeah. So one of the very exciting areas in machine learning now is this whole idea of physics guided machine learning.
Hmm.
So in domains where you know something about the underlying physics, so for example, there may be some conservation of flow or momentum or something, or there may be some entities that you're predicting, but they're all related by some partial differential equation. So this is, already known knowledge. So you can actually use this kind of knowledge to guide your data-driven machine learning solutions. And what you end up is not only more reliable, more accurate solutions,
Yep.
but also solutions that are more reliable and more understandable.
Yep.
And as I said, those are two important aspects of a solution being trustworthy and hence more likely to be adopted. So this whole physics guided AI or ML, I think is a really exciting area. Much of the progress has just happened in the last 2 years.
Yep.
But eventually, a lot of what these computational, scientists or engineers would do can be done with a combination of their skills and the data-driven
No,
models.
even you started the conversation on like how most of the AI earlier was more symbolic in nature, and
Yeah.
now it's all data
Mhm.
driven. And this whole hybrid approach, when you can combine the two, is really I'm also personally very excited about that space too. And I think because it's a notion that it's an iterative problem, and the more expertise you can augment into the problem solving process, you can actually get to a better solution. So we're kind of running out of time. This has been a fascinating conversation. I have a few more quick questions for you, but before that, um, give me some practical advice for organizations and executives looking at this, watching this video, and say if they're about to scale their AI journeys or they're looking to get started in AI, what is some practical advice you have for them?
Firstly, do not be afraid. If you try to, take out all the risk before you make this transition, then you'll be left way, way behind the crowd. So it's not a magical technology, but of course, there's a lot of science and solidity behind it. You want to take the leap in a proper amount of caution. First thing, you want to think carefully about your data and your quality of the data and so on, because These are primarily data-driven methods. So if that's really compromised, then garbage in, garbage out. And also try to build everything on your own. Work with companies and experts who have done this, because a lot of it is, some of them is not, there's a fixed formula that, I need to use toolkit A with data set B, and that will solve all my problems. So that experience, does take a while to develop. Even a good data scientist right now can do far better than AutoML. So, even the AutoML has not reached that part. Um, and think about what business problems you want to solve, and whether the nature of it is well matched to AI capabilities now or in the near future. Um, because just because AI sounds so cool doesn't mean that you need to apply it to yours. In fact, one of the things I've seen is till I would say maybe 7, 8 years back. So since I was on the academic side,
Yep.
so AI was the art of the impossible. So once you solved a problem, it was no longer AI. So for example, in the 1960s, optical character recognition was considered an AI problem. But then people, at least for typewritten characters, numbers, they could recognize that. So there was no longer AI, right? And again, after, Deep Blue beat Kasparov in chess, the chess playing basically went out of the AI literature because that was solved. Okay, so all these throughout history, AI was those big, long, big, hairy problems that we cannot solve, and now it's become just the opposite.
Yeah.
AI will solve all the problems in your life. Take care of your indigestion, make you money, all those things, right? So it's gone completely the other end. In fact, most startups are worrying that they're not doing enough AI. So the thing is, it's a very cool technology, but it is a technology, and that means that some cases it really help you, and but other cases it's not appropriate.
That's
Right?
yeah. No.
So if I was just practicing tennis, so if I want to figure out the trajectory of my ball, there's Newtonian mechanics. That's probably good enough. I don't need to, you know, do 1,000 serves and try to feed that into my AI algorithm to figure out what's going on.
Yeah. That's
Right?
fascinating. No, you're right. I think, but on the other hand, though, I would argue also, AI was very much like an exotic technology back then, right? So,
Exactly.
and
Yeah.
then so naturally you're applying it only to solve the problems you cannot otherwise solve. Now, because of the democratization of the research and now the compute and data being a lot more easily and cheaply available, it's now
Right.
provided the opportunities to start looking at it and saying, if I don't want to do this thing, it's maybe an easy task, but I don't want to do this. I just want my little digital twin to do that part. I mean, probably that's the perfect application for AI at the service of
Yeah.
humanity, for the human to do the work that you don't want to do, right? So, but it's an interesting history lesson when you think about it, right? Like back then, as the AI was the art of the impossible. Now, in
Yeah.
fact,
And that's why it was very exotic.
even the
Exactly.
IBM ad, it's all about just the art of the possible. Just make sure that you focus on the ones that are mundane, easy, so the humans
Yeah.
can focus on the impossible to solve big problems, right? I think the one common thread, of course, is the fact that AI is a tool among many tools to improve our business, our lives, or the way we live, and and everything. So I got a couple of really quick, rapid fire questions for you, Joydeep, and we'll get
Sure.
your. Want to give me your quick takes. First question: AGI. Do you worry about
Mhm.
it? Are we going to see that in our lifetime? What are your thoughts?
Probably not, and that's the general academic consensus. Though I think, seemingly we have made great progress, things like GPT,
Hmm.
but normally people don't think it's going to happen
Yeah.
in the next 25 years, at least, despite what Elon Musk says about it.
Yeah.
Yeah.
Okay. I mean, I think so. I qualified the question by saying in our lifetime, but if we really
Yeah.
make the improvements in biology and bioinformatics and stuff, we might actually live longer to actually see that happen too, right? So
Yeah, that's why I said
the next 25
25
years.
years, because Daphne Kohler, who's the co-founder of
Yeah.
Coursera, She's working in a company to try to make us live very, past 200 years. I don't know why you want to do that, but that's what she's trying.
That's awesome. Okay. Question two. This is more a personal question. What is one personal practice that you employ that to keep you at the top of your game?
Well, one thing is to be, this is such a rich area. There's so many new things coming up that you want to keep track of all the, new ideas that are coming. But you also want to be very careful in choosing your sources because right now, so many people have become AI experts, and I don't know where they came from, right?
Yeah.
Of course, they're real experts too. So there's a lot of noise, and social media does not has not helped the cause.
Yeah.
So yeah, and constantly think about the basic capabilities that AI brings you, and think creatively about what business problem can be solved using that. So I think a lot of it, as the technology matures, it wouldn't be the thing of question of coming up with new algorithms or capabilities, but using capabilities already available in creative ways to solve business problems.
Awesome. Awesome. If somebody wants to learn AI and they're watching this video as the first time, what's one resource you would point them to?
Oh my gosh. Well, sorry, I'm the academic, so there's the standard book by Russell and Norvig. But by the way, but I'm not saying go read this fat book. If you go to the Berkeley website, they actually have not only lectures, but they have a lot of videos you can watch. So that'll be, give you some sense from the technical side. From the more business side, so some of the VCs who fund AI companies like Andreessen Horowitz, this AZ16, there's some really well-produced videos that talk about what AI can do for you. And if you go through them, you'll get in some at least creative juices flowing as to how I can use this technology for my own interests.
Awesome. Awesome. Joydeep, this has been a true pleasure. How can the viewers and listeners get in touch with you? Where can they find you on the internet?
Gosh, well, Google knows everything about me. So if you just Google my name, which is there, I think, so you know more about me than you ever cared to. Yeah,
Okay, I'll add your
including my email address.
LinkedIn
Yeah,
and yeah, and
yeah.
Twitter too. So, uh, Joydeep, this was such a pleasure. Really enjoyed the conversation. As always, all our lunches and meetups is always it leaves me energized and really excited about what's possible in this space. And thank you so much for taking the time.
Thank you, Ganesh, for this opportunity.
Awesome.
Yeah, have a good weekend.
You too.
Yep.